Are you a mechanical design engineer and just started exploring AI? Do you want to know what AI is capable of? In today's video, we will discuss how AI can be used in actual mechanical design workflows. We will explore how AI is becoming a partner of new product development process of industries like heavy machineries, automobile, and robotics. Let's start with the basics. What exactly is AI? AI, or artificial intelligence, is a branch of computer science that focuses on creating machines or software that can perform tasks that normally require human intelligence. That means learning from data, identifying patterns, and making decisions with minimal human intervention. It starts with collecting large amounts of data. This data can include text from books and websites, images like photos and drawings, sounds such as speech and music, and numerical data from sensors or statistics. Once the data is gathered, AI uses a method called machine learning to identify patterns, much like teaching a child by showing many examples. For instance, to teach an AI to recognize cats, it has shown thousands of cat images, allowing it to learn common features like ears, eyes, and fur. AI systems rely on algorithms, step-by-step instructions, and often use neural networks, which mimic the structure of the human brain. These networks consist of layers of interconnected nodes that process information and learn complex patterns. After training, the AI can make predictions, recognize objects, understand language, and even generate content. Over time, AI can continue to improve by learning from new data, a process known as continuous or reinforcement learning. A simple example of AI in action is using voice commands on a phone. When you say, "Play my favorite song," the AI converts your voice to text, understands your request using natural language processing, searches your music library, and plays the song, all within seconds. In mechanical engineering, this doesn't mean robots drawing sketches. It means software tools that can learn from past designs, simulate performance, and suggest improvements. Think of it as having a virtual co-engineer who never sleeps and keeps getting smarter. Let's dig into 4 key areas of the mechanical design process where AI can play a transformative role. First one is generative design. Traditionally, mechanical design involves human engineers creating parts manually using CAD software. The designer defines shapes, sizes, and features based on experience, calculations, and design rules. It's a creative but time-consuming and iterative process. But with AI-powered generative design, the workflow is flipped. You tell the AI your design goals, not the final shape. Instead of manually drawing the part, you provide the AI system with specific inputs that define the design requirements. These inputs include the objectives, such as minimizing weight, maximizing strength or stiffness, and ensuring the part can handle specific loads. You also set constraints, which are the physical and engineering limits the design must follow. For example, you might specify that the part must be made from aluminum, must fit within a certain space, and cannot be thicker than 10 millimeters due to manufacturing restrictions. Additionally, you define the load conditions and supports, which describe how the part will function in the real world, such as where it will be fixed, where forces will be applied, and how much load it must carry. Based on all this information, the AI then explores a wide range of design possibilities that meet your criteria. AI-powered tools can analyze vast data sets of existing designs, patents, and engineering standards to generate innovative design concepts. However, it's important to remember that while AI can generate a wide range of ideas based on available data, it's your responsibility to verify both the input data and the final results. AI is a powerful assistant, but human oversight is essential to ensure accuracy, feasibility, and reliability. Next is simulation acceleration. Traditional finite element analysis, or FEA, is a powerful but time-consuming method used to predict how a part will respond to forces, heat, or other physical conditions. It involves creating a detailed mesh, applying loads and constraints, and solving complex equations across thousands or even millions of elements, often taking minutes to hours, especially for complex designs. AI addresses this challenge through techniques like surrogate modeling and machine learning. Using these methods, AI can learn the complex relationships between input parameters, such as geometry, material properties, and loading conditions, and output responses like stress distribution, deformation, thermal gradients, or vibration modes. A surrogate model is a simplified, fast-running approximation of a complex and computationally expensive simulation or process. Think of it as a stand-in or digital twin that mimics the behavior of a real simulation but runs in a fraction of the time. How does it work? The process begins with data generation. Engineers run a series of high-fidelity simulations, such as finite element analysis, FEA, or computational fluid dynamics, CFD, across a wide range of input parameters. These inputs might include variations in geometry, material properties, boundary conditions, or loading scenarios. The goal is to build a comprehensive dataset that captures how different design choices influence performance outcomes like stress, temperature, or displacement. Once this dataset is prepared, the next step is to train a machine learning model. The model learns to approximate the relationship between the input parameters and the simulation results. Essentially, it becomes a mathematical shortcut that mimics the behavior of the full simulation without needing to solve the underlying physics equations every time. After training, the surrogate model is ready to make predictions. When given a new set of input parameters, it can instantly estimate the corresponding output, such as stress distribution or thermal response, without rerunning the full simulation. This dramatically speeds up the design process, enabling engineers to explore more design alternatives, perform real-time optimization, and make faster, data-driven decisions. Next is design optimization. Design optimization is a critical phase in the engineering process, where the goal is to find the best possible design configuration that meets multiple performance criteria. Traditionally, this process involves numerous iterations, manual adjustments, and time-consuming simulations. However, with the integration of AI, this landscape is rapidly evolving. AI, particularly through machine learning and evolutionary algorithms, enables a smarter, faster, and more efficient approach to optimization. Here are 5 key areas where AI can step in to provide an optimized design solution. First, geometry optimization. AI algorithms can analyze and refine component geometries to achieve optimal performance. For example, they can minimize weight while maintaining structural integrity, or reduce material usage without compromising strength. Next, multi-objective optimization. In real-world engineering, designs often need to satisfy multiple, sometimes conflicting objectives such as maximizing strength while minimizing cost, or improving thermal performance without increasing weight. AI excels at handling these trade-offs by identifying a set of optimal solutions, allowing engineers to choose the best compromise based on project priorities. Next, reduced design iterations. AI models can predict promising design configurations early in the process, significantly reducing the number of trial and error cycles. This not only saves time but also accelerates product development and reduces costs. Next, exploration of large design spaces. AI can evaluate thousands or even millions of design variants quickly, something that would be impractical with manual methods or traditional simulations alone. This broad exploration increases the chances of discovering innovative and high-performing solutions. Finally, real-time decision support. With AI integrated into CAD and simulation tools, engineers can receive real-time feedback on how design changes affect performance. This enables faster decision-making and more agile development cycles. By analyzing these trade-offs simultaneously, AI helps engineers arrive at the most efficient design much faster than traditional trial-and-error methods. Let's get practical. Say you need to design a lightweight, strong shaft for a motor. Traditionally, you'd pick a standard size, run some calculations, and maybe simulate the stress. With AI, you set the constraints, like required diameters and strength limits, and let it optimize the shape. The AI tests thousands of variations, adjusting thickness and curves along the shaft, all while keeping stress within safe limits. In minutes, it finds a design that's lighter and just as strong, maybe 20% less material than your original. The result isn't a plain cylinder, but a contoured, efficient shape you might never have considered. You save weight, material, and energy, all thanks to AI's number-crunching power. Now, how can you start using these tools yourself? Ready to try these new techniques using AI? You don't need to be a computer scientist. Many CAD programs already have AI features built in. Start by exploring your software for tools like Generative Design or AI-driven simulation. Watch a few tutorials online, then experiment with a simple project, like a shelf bracket. Set the constraints, let the AI generate options, and see what it comes up with. Treat it as a collaboration, you set the goals, AI explores the possibilities. Once you're comfortable, learn a bit of Python, the go-to language for AI and data science. Free resources like Codecademy or Free Code Camp make it easy to start. Understanding the basics will help you use AI tools more effectively in your projects. Don't get overwhelmed, start small, experiment, and build your skills step by step. The future is coming fast, and hands-on experience is the best way to keep up. Let's look at what this means for your career. AI isn't a fad, it's redefining engineering. The best engineers will be those who know how to work with AI, asking the right questions, setting smart constraints, and interpreting results. AI handles the repetitive calculations, freeing you to focus on creativity and big-picture problem-solving. This is the new normal, a partnership between human ingenuity and machine intelligence. By learning these tools now, you'll be at the forefront of the next engineering revolution. Don't be intimidated, start with small steps, keep learning, and embrace the change. The future belongs to engineers who collaborate with AI to build smarter, more efficient, and more amazing things. The tools are in your hands. Go out there and build the future.